term in geometric progression. So let's use a geometric progression, and thereafter by using the nth term formula we can easily identify the nth term of a geometric progression. So I'll use 2, 6, 18 and 54. This is my geometric progression. So no need to prove this one as a geometric progression again, because I have mentioned this one as the geometric progression. So this is already a geometric progression. First what we can do is the Tn, nth term. So we can use Tn notation to indicate nth term. For that there is a formula A into R times, this dot is indicating multiplication, A into R times power of n minus 1. This is the formula. A into R times power n minus 1. By using this formula, we can find Tn of a geometric progression. Before that, you should identify A and R. What is our A? A is the first term of this geometric progression. That is 2. Directly we can write. Then R. R would be, I will select 6. 6 divided by 2. 6 divided by 2, it is 3. Okay. A into R to the power of n minus 1. So I will substitute that one here. Tn is equals to A is 2 multiplied with 3 times to the power of n minus 1. We don't know the n value, so we cannot substitute that one here. And one more thing, do not multiply these two, okay, because it doesn't have any powers, but it has a power. No, it has a power, so we cannot multiply them directly. You have to keep it as it is. So this would be the simplification of Tn, nth term of a geometric progression. Hereafter we can do several things. In the same question, if I ask find the 10th term, not 10th, find the 5th term, 5th term in the same geometric progression, which means I am asking T5. We can write the first term as T1, term 1, term 2, term 3, term 4. Likewise, the n term, the hypothetical term in terms of n, we can denote by using this formula. You should remember this formula, Tn equals to A into R to the power of n minus 1. We got the simplified version of our answer, and thereafter T5. So what happened here was n was replaced by number 5. If there is a 1 here, you should substitute 1 here to find first term. There would be a 2 here, substitute 2 here to find the second term. Likewise, my question is to find fifth term, T5. 2 times 3 to the power of, instead of n, we need to substitute number 5. 5 minus 1. So 2 times 2 multiplied with 3 to the power of, from n we cannot subtract 1 because n is a variable, 1 is a number. We cannot subtract this. But from 5 we can subtract 1. So 5 minus 1, 3 to the power of 4. 2 into 3 to the power of 4 means, 3 to the power of 4 means 3 multiplied with 3 4 times, not 3 multiplied with 4, okay, not 3 multiplied with 4. 3 should be multiplied 4 times. So 3 into 3, 9, 9 into 3, 27, 27 into 3, it is 81. 2 times of 81, it will give you 162. 162, that would be the fifth term of this particular geometric progression, 162. From the beginning I'll explain, have a look. Only the expression given, to find Tn we have to use this formula. We should use A into R to the power of n minus 1. A is 2, R is 3. Just I substituted A and R value. I kept it as it is as Tn formula. Then my question, in the same question, same question series, the question is fifth term. So n should be substituted by number 5. Thereafter simplification, we can have this fifth term as 162. So in the formula, all the necessary details were given. You should find T6. T6. A is 5 multiplied with 2 with the power of n minus 1. N is 6, no? 6 minus 1. So 5 multiplied with 2 with the power of 5. So 2 with the power of 5, when we multiply that, that is not 10, that would be 32. 5 multiplied with 32, it would be 160. That is our sixth term. So for the T4, T4 would be A, substitution of A, that is 4. R is negative 2, so I'll keep it inside a bracket to ensure the negatives are multiplying. And n minus 1, n is 4. 4 minus 1. 4 times negative 2 to the power of 3. Negative 2 to the power of 3. 4 times negative 2 to the power of 3. 4 times negative 2 to the power of 3 means you should multiply negative 2 into negative 2 into negative 2. Negative into negative positive, positive into negative negative. 2 twos are 4, 4 twos are 8. So the answer would be negative 32. Fourth term, that is negative 32. And next T6. For that one, 4 times negative 2 to the power of 6 minus 1. The power is 6. 6 minus 1. 4 multiplied with negative 2 to the power of 5. When we multiply negative 2 5 times, it will become negative 32. 4 multiplied with negative 32, it would be negative 128. These are the correct answers. In this question, first term is 1000. So I'll write A as 1000 and common ratio, which is 1 upon 5. Previously, I mentioned that if you want, you can make it as a decimal. That is not compulsory, but if you want, you can make it as a decimal. I'll use both decimal and fractional method to explain the question. T6. First, I'll use the decimal. A is 1000 multiplied with 0.2 with the power of n minus 1. N is 6. 6 minus 1. 1000 multiplied with 0.2 with the power of 5. So 0.2 with the power of 5 means you should multiply 0.2 5 times. Let's multiply that one. So instead of dealing with this decimal, most comfortable method is to handle with the fractions. So if you use, so I will make the decimal as a fraction. 2 upon 10. 2 upon 10 into 2 upon 10. Another 2 upon 10. 5 times. Another 2 upon 10. 0.2 as a fraction. Thereafter we can simplify 0, 0, 0, 0, 0, 0. Then we will have 32 divided by 100 in denominator. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32. In denominator 10 tens are 100. So finally you will have 0.32. This would be the sixth term. This would be the sixth term. If not, if you are compatible with the fractional method also, no problem. I will explain. T6, that is 1000 multiplied with 1 upon 5 with the power of 6 minus 1, it would be 5. Same thing there as well. 1000 should be multiplied with 1 upon 5 5 times. So you can give 1 with the power of 5 and 5 with the power of 5. This is a suitable method. Take a look. The 1 into 1 with the power of 5 and 5 with the power of 5. 1 with any index, doesn't matter any index, it will give you 1. So 1 multiplied with 1000, it is 1000. Thereafter in denominator you will have 5 with the power of 5. 5 into 5, okay, 5 into 5, that is 25. 25 into 5, 125. 125 into 5, 625 into 5, 3125. So when we divide this 3125, so you should divide 1000, the numerator by denominator, you will have the answer as 0.32. There also. You can use the suitable method according to your convenience. This one or this one. That is your convenience. But both are suitable methods. Finally, you will have the same answer. So for the fourth question, T6 directly question is asking about T6. So what you have to do is, first of all, you should find A and R value. A is 192. R is 96 divided by 192. It will give you 1 upon 2. 1 upon 2, 0.5 you can use. So I'll use this one as 0.5. Then just substitute it in the Tn formula. T6 equals to A is 192 into R is 0.5. 0.5 with the power of n minus 1. N is 5. Sorry, n is 6. So 6 minus 1, it would be 5. Here it should be 5. 6 minus 1, 5. 192. I will make this particular decimal as a fraction. It is little hard to handle with the decimal, so I will make it as a fraction. 5 upon 10 multiplied with 5 upon 10 multiplied with 5 upon 10 multiplied with another 5 upon 10. No. Just 5 upon 10. All would be simplifiable. Okay, that is easy. 1, 2, 1, 2, 1, 2, 1 5s are 5, 2 5s are 5 is 5, 2 5. Then 2 into 2, 4, 4 into 2, 8, 8 into 2, 16 into 2, 32. So 192 divided by 32. Overall, what is happening? Give us 192 should be divided by 32. That will give you 6. T6, that is 6. 192, that is multiplied with 5 1 values in the numerators. Thereafter, the answer would be 6. This is equals to 6. In denominator, 2, 2, 2, 2, 2 with the power of 5, so 32. That will give you number 6. For the last question, what we need to do is same thing. A and R. A is 8 directly. R would be 12 divided by 8. Here, when you divide, you will have 1.5. Okay, 1.5. Thereafter, if you want, you can make it as a fraction as well. We both are 4 multiples, so we can make it as either 1.5 or 3 upon 2. Both are easy. I will use the fraction method here. T5. So T5 equals to 8 times 8 multiplied with 3 upon 2 with the power of 5. N is 5. 5 minus 1, 4. Thereafter, 8 should be multiplied with 3 with the power of 2, 4 times. 3 with the power of 4 and 2 with the power of 4, because this fraction consists of an index. Both denominator and numerator also have the respective index itself. 8 should be multiplied with 3 with the power of 4 means 3 into 3 9, 9 into 3 20, 7 into 3 it is 81. In denominator we will have 2 with the power of 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. So this is 8 and 16 simplified 2 times 1 time, then finally 81 divided by 2, that will give you 40.5. 40.5. That would be the fifth term in this geometric progression. I told you that geometric progression, the number, it can be a negative one, it can be a fraction, it can be a decimal. There are many other suitabilities as well.